Example 5 is a little bit different than the ones we've seen, so check this out. We have two functions, x equals 3 minus y squared and x equals y plus 1. The big difference here is these are functions of y instead of functions of x. So what we're going to do is graph these. Now, think about it as a function of y. This is still a parabola. It is opening to the left. Remember, our parabolas, when they're functions of y, open left or right, and it's shifted right 3. So this is kind of what it looks like going this direction. I don't know how accurate that is, but that was pretty good. I don't know what the intercepts are. I didn't calculate them. This, if you want to solve that for y, you can. That's going to be x minus 1, and we can just graph that. So y-intercept negative 1, slope of 1, so it's going to look like this. All right, so what we see here is we want to find the area bounded by it, so we're looking for this region here in the middle. Now, if we're doing this the way we have been doing it, top curve minus bottom curve, that is fine from this point to this point. We have a definite top curve and bottom curve, but then once we get past here, the top and the bottom curve are the same thing. They're both that parabola. So when we have functions of y instead of functions of x, it's easier to do, instead of top minus bottom curve, to do right minus left. So it's going to look the same, but instead of top minus bottom, it's going to be right curve minus left, and we will be as a function of y instead of x. Try that again because you can't see it with the glare. There, can you see that? dy. Okay, so we're going to do this integration. Our right curve is the parabola, so 3 minus y squared. Our left curve is the line. All right, and we need to know our 2 points here. Those are going to be y values, and we're going to find those by finding out where those two graphs intersect. So just like we did on the other problem, we're going to set those equal. So 3 minus y squared equals y plus 1. I'm going to move everything to the right. Y squared plus y minus 2. I'm going to factor that. And we find that y is negative 2 and 1. So this point has a y value of negative 2. This point has a y value of 1. My graph was actually pretty good. So that's what we're going to evaluate from. So real quickly, I'm going to clean that up. It's negative y squared minus y plus 2. And then we'll take the antiderivative of that. Negative 1/3 y cubed minus 1/2 y squared plus 2y. And we're evaluating from 1 to negative 2. I've got the space, so I'll go ahead and plug this in. That's going to give us negative 1/3 minus 1/2 plus 2. This will give us 8/3 minus 2 minus 4. And when we put that all in, I'm going to go ahead and just go straight to my answer that I got, 9/2 again. I think that was just like the problem we did, the first problem we did, or second problem we did, just in the y direction. So you can do these either top minus bottom, and that is going to be in terms of x, or you can do right minus left, and that would be in terms of y. In the last video, I'm going to show you how to use your calculator or use Desmos when we have functions that are a little bit more complicated.